Concrete. It's the foundation of our entire modern world, right? Bridges, buildings, runways. It is everywhere. And we tend to think of it as, permanent. But it has this hidden vulnerability, a fundamental weakness that leads to really expensive decay. So what if you could turn that weakness into its greatest strength? Well, a technology called Vetrofluid claims it can do just that by changing the very nature of concrete from the inside out. So here's how we're going to break it down. First, we'll get into concrete's core problem. Then we'll introduce this totally different kind of solution, Vetrofluid. After that, we're going to walk through the hard data from a whole gauntlet of tests, see how it actually performed in the real world, and finally, take a look at what this all means for the future of, well, everything we built. All right, let's dive right in. Section 1, the concrete conundrum. For a material that's so important, the way it breaks down is a massive, ongoing headache for infrastructure all over the world. And this is what that failure looks like up close. This is a runway at Las Vegas McCarran International Airport. You can see the surface is just crumbling away. That's a process called spalling, where the aggregate, the little stones in the mix, is literally falling out. This isn't just a cosmetic issue. This is structural decay live in action. And it's caused by a whole host of enemies. The biggest one? Water. It gets in and brings salts and other chemicals with it. And in cold climates, that water freezes, it expands, and it cracks the concrete from the inside out. That leads to all this stuff. Spalling, erosion, and eventually the corrosion of the steel rebar that's supposed to be holding the whole thing together. So, Section 2, a deeper solution. Now, most ways we protect concrete are basically just a surface treatment, kind of like paint. But the approach we're about to look at goes much, much deeper. So let's meet Vetrofluid. At its heart, it's a formula based on something called water glass, or sodium silicate. But thanks to a special catalyst, it's designed to do something pretty unique. It soaks deep down inside the concrete's porous structure and creates a permanent internal barrier. So it's not a coating, it's an impregnation. It becomes part of the concrete. And this slide really nails the difference. See, your typical sealer just forms a film right on top. That means it can get worn away by traffic, it can peel off, and you have to reapply it every few years. Vetrofluid, on the other hand, sinks in. We're talking up to 40 millimeters deep, and it actually reacts with the concrete to become a permanent part of the structure. It's a one-and-done treatment that can't wear off because there's nothing to wear off. Okay, those are some big claims, and big claims demand serious proof. So in Section 3, we're going to look at the hard data from independent lab tests that were designed to see if this technology really holds up under pressure. First up, blocking chlorides. Those aggressive little ions from de-icing salts that make rebar rust. In tests by SGS Tech Services, they basically flooded concrete samples with chlorides. And just look at the difference. At every single depth, the Vetrofluid-treated sample has way, way lower chloride content. I mean, down at 25 to 35 millimeters, it's blocking more than 2/3 of the ions compared to the regular concrete. That's huge. Now this chart gets to the real root of the problem, water. The Polish Air Force Technical Institute found that regular concrete soaked about 3.8% of its weight in water. After the Vetrofluid treatment, that drops to just 1%. By blocking the water, you're stopping the main cause of that freeze-thaw damage and all those chemical attacks right in its tracks. But this is the number that changes everything. The same institute ran pull-off tests, which is basically them trying to rip the surface layer of the concrete right off. The Vetrofluid-treated concrete was 95.2% stronger. It's not just protecting the concrete, it's actively making it stronger. So the really key point is how it failed the test. And the CEO of EcoBeton UK explains it perfectly. In a normal test, a coating would just peel off. But here, the Vetrofluid bond was so incredibly strong that the concrete underneath it broke first. That's called a cohesive failure. The treatment literally made the surface layer stronger than the original concrete it was bonded to. That's the best possible result you can get. And this stuff isn't just for heavy industry. It's been tested like crazy and certified as completely safe for use in things like drinking water tanks. It's odorless, it's non-toxic, and it doesn't leach any harmful chemicals, which just opens up a whole world of possibilities for all kinds of sensitive jobs. Okay, so lab tests are one thing, but how does this technology hold up in one of the most demanding places on Earth? Section 4 takes us from the clean room of the lab to a blistering hot runway in Las Vegas. This thing is called a strip hog. Its job is to blast rubber off runways using water jets at an unbelievable 36,000 psi. It's an extreme form of abrasion. And at McCarran Airport, they use this machine not just for cleaning, but to simulate years of intense wear and tear in just a matter of minutes. And the results are, well, they're just stunning. On the left, you can see the untreated concrete after the test. It's all chewed up, the aggregate is totally exposed. Then on the right, you have the Vetrofluid treated section hit with the exact same blast, and it's virtually undamaged. This is as clear a real-world confirmation of that lab strength as you could ever hope to see. They even tested it on that old, failing concrete we saw at the very beginning. Now, before the treatment, the crew could literally pry the loose stones out with hand tools. But after applying Vetrofluid, the report says the hardened concrete paste became so strong and so well bonded that they had to physically chip it out. It didn't just protect the weak concrete, it actually healed it. All this evidence really points to a new possibility for the future of concrete. So in our final section, let's just explore what it means to build for longevity and resilience right from the very start. So let's wrap up the core advantages that we've seen proven by the data. Number 1, it permanently waterproofs the concrete matrix. 2, it structurally enhances it, nearly doubling its surface strength. 3, it protects it from the inside against its worst enemies. And 4, and this is a big one, because it's a permanent one-time treatment, it dramatically cuts long-term maintenance costs. And that just leaves us with a final thought. We've always kind of accepted that concrete, for all its strength, is porous and vulnerable. But what if that's just not true anymore? What if its biggest weakness, its porosity, could be turned into the very thing that makes it permanently strong and resilient? That really changes how we think about everything we build.